Hello, this is the course of Introduction to Data Science, and in this video I would like to continue the lesson on the basic Numpy. So we have the section 1 and section 2 before. Were discussing about how to make array in the Numpy environment, and we are dealing with some operations in the Numpy. And in the section 3, we are going to learn about the aggregations. So some of them are related to minimum, maximum, and everything in between. So in this section, we are going to learn just the basic one. Yeah. And when we have the large amount of data, so actually we need to compute the summary statistics. The summary statistics are like related to mean, average, and then the count or median, or the something related with the minimum, maximum, quantile, and etc. So there are many other summary statistics. Okay, so instead of the mean and standard deviation, we can also get the other kind of measures like sum, product, median, minimum, and maximum, quantiles, and etc. And we are going to discuss that one from this chapter. Okay. So first, we're going to discuss about summing the value in an array. In Numpy, okay, we remember that we need to import. So we import the Numpy library, and we will use NP in all the codes. You can see the random function that we use here, and then let's say, okay, let me just split this one. So first, I would like to make a random function. Okay. After I make the random function, let's see the result L. So this random function is any value, okay, any value between 0 and 1, and I would like to generate 100 values. And among all the 100 values, I would like to sum. So sum, you know, what is the sum? Sum based on the English meaning. So we want to calculate the total. Okay, so the total from every element, there will be the sum. So if you run this, then the total is like 50.33. You can use this one is the basic summation function. In the NP, it has the np.sum, yeah, and you will see the result. If you see from those two cells, the sum L and the np.sum L, it seems you can just say that, okay, I can use the cell number 3 and I can use cell number 4. However, actually both of them are different, yeah, because the Numpy version of the operation is computed much more quickly. It means when you deal with the big data, it will help you to see the result in short time. So I would just want to show this one. Okay, let's say I have a very big array. Okay, I don't want to run this. I don't want to show the result of the big array because it's very huge number. So there will be like 1 million. Okay, there will be 1 million numbers, and then I would like to do the summation with the function in Python, and I would like to do the summation with this NP. NP is from the NumPy, and I would like to know the time. Yeah. So if I run this, it depends on your computer. Okay. And after you run this one, you can see the difference of this result. Okay. So you can see that the sum function and the NP function are not identical, and which can sometimes lead to confusion. In particular, some optional arguments have different meaning. NP.sum is aware of multiple array dimension, so we can see later, okay. But now you can see that the result here is different. Yeah. So we can see the summation has only like one loop each, but the result on the np.sum with this big array, it result like 1000 loop array, and yeah, the second is very small. You know, this is millisecond and this is microsecond. Okay, so the speed is also different. If I want to find also the minimum and the maximum, if you already join the data structure, you will know that if we want to find the summation, then you will do like one by one from the first until the end. But there will be many ways to calculate the summation and the minimum and the maximum. And one of the way is, yeah, if we are dealing with very big data, there should be a way like the tree, binary tree, or yeah, the hash code and etc. So if I want to find the minimum, yeah, this one is one default function from the Python. And let's suppose we want to find with the NP. NP is from the Numpy. Okay. So the results are the same, but what is the difference? Yeah, it's also the same idea with the summation. The NP will give you a very efficient operation when you are dealing with the very big data. So this is the process. Okay? So now the Python is trying to get the operation time. Okay? So you can see here now the minimum function with Python, it produce like 167 millisecond, but for the NP, it shows microsecond, so very small number, and it produce very fast result. Yeah. And if you want to combine with every of the functions in the NumPy, yeah, it will produce the result very fast. Okay, so that's why the NumPy is very useful, especially when you want to use like deep learning method. And this NumPy will be very helpful for your computer. And if you want to do it like Google Colab or with a good server or with your laptop, for example, then this NumPy operation will be very helpful. And if you are doing with the multi-dimensional aggregates, okay, yeah, this one is also the same. Yeah, we have the random function, and then let's say this is 3,4. You already know if we have the 2-dimensional 3,4 means we have 3 rows and 4 columns. And yeah, let's see this one, 3 rows and 4 columns, and this is the random number, and you want to calculate the summation for all. Okay. Yeah, I'm just using this m.sum because you know that the random value are basically it is from the NumPy. So you can just access the NumPy by calling the variable name, and you just call the summation. If you want to find the minimum, yeah, so you want to find the minimum from the axis 0. What does it mean? So the aggregation functions takes an additional argument specifying the axis along with the aggregate is computed. For example, we can find the minimum value. So I want to find the minimum value within each column by specifying axis equal to 0. So if you're dealing with the column, so just mention about the axis, okay, and you will find the minimum among the column. Okay. So this one is the minimum of the column 1. This is this is if we are dealing with this one, column 1, column 2, column 3, column 4. So this is the minimum in column 1, column 2, column 3, column 4. Okay. If we want to see in the row wise, okay, so the x is 0, I can see this is the column wise, okay, and the other way it is the row wise. So row wise means the row aspect, okay. And it means the first row, the maximum value is 0.9 and something. This is the maximum value of the second row, and this is the maximum value of the third row. Okay. So this axis, it can be confusing, okay? And the axis keyword specifies the dimension in the array that will be collapsed rather than the dimension, okay? So be careful when you do the axis 0, axis 1. So remember that axis 0 belongs to column and axis 1 belongs to row. Specifying axis 0 means the first axis will be collapsed into dimensional array, and this means that the value of each column will be aggregated. So later, if we are dealing with the aggregation function, then there will be also some other meaning. Okay, we will check later some other aggregation function that you may use. So I will also explain this in the later part. There will be some other function for the statistical descriptive result. And before I explain this function, I would like to notice that when you want to aggregate, you need to be very careful when you have the NaN. Okay? So NaN means not a number. Okay? So if you are dealing with this NaN, okay, we call this is NaN. Maybe I just wrote this one. NaN equals to not a number. Okay. So when you're dealing with the NaN, which is not a number, the function will not work. Okay. So it will try to ignore the value. So whenever you have your data, I really hope that you can have a good data set. So whenever you put the function, it will work properly. There are many function names. I cannot discuss those details now, but I guess you know from the name like np.sum, so you want to do the summation. np.prod, it means you want to compute the product. The product means the multiplication. np.min, you want to find the mean. np.std, you want to find the standard deviation. var, it means you want to find the variance, minimum, maximum, argument, minimum. So you want to get the index. Yeah? You want to find the index which is the minimum value. Argument max, you want to find the maximum, the index of the maximum value. The same with median. And you want to get the median value. Percentile, so you can just measure what is the number of percentile, 20%, 30%, and etc. np.any, so you want to evaluate whether any elements are true, and all means you want to evaluate whether all elements are true. And if you have the NaN value, you need to put the NaN sum. So np.nan sum, np.nan prod, and so on. Okay, so this column provide the method when you have your data set with the NaN value. But this function, you can just apply with your data set whenever there is no missing value. Okay, I would like to give you one example about how to use the function in Numpy. Before I enter this example, I would like to mention that this is just a very basic data analysis from this chapter. In this section, I would like to use one data set, which is about the head of US presidents. Okay? So the data set is available in the file presidentHead.csv. So you can take this file in the e-class. Okay? And it is a simple comma separated list of labels and values. So CSV means comma separated values. So I will explain this kind of data set in the next video. But for now, you can just use this data, and yeah, we will learn more about this data. And for this section, I would like to use one of the important package for our analysis, which is the pandas. Okay, so pandas is the Python for analytical data science. Okay, and yeah, we will explore more later, but now let's just use pandas to read the file. So you can import pandas as PD. So PD is the short of the pandas, and I would like to read the data president underbar heads. So if you are using the Jupyter Lab, it will be very convenient for you, because now you can see that in this folder, so the file that I put the Jupyter notebook files, there is one new folder which is data. So if I click the data, yeah, so please put the data that you got in your if the data in your e-class, please put in this folder. So when you already put the file in this folder, then you will see the president underbar heads.csv appear. So if you have this data, then it is correct. Okay. Okay, remember, you can make a new folder. So you can make this one new folder. Yeah, so you can just put the data, for example, because I already have the data, so I will just delete this one. And then, yeah, you know where is the folder is, and just put the file.csv in this folder. And after you have this folder, I guess I need to, okay, let me split these two, okay, and then I will just put here, and let's read the data. I guess, yeah, you can run this. So it takes some time to import the pandas. And after you read this one, okay, let me see if I run this data. Okay, so the data is the contents of this CSV file. Okay, you want to read from the folder data, and in the folder data there is a file president heads.csv, and this is the data. The order is the first column, name is the second column, head is the third column. So order means the president order. This is the first president, George Washington, the second president, John Adams, the third president, Thomas Jefferson, and so on. And this is the head information. So using this head information, you can see, yes, all of them are the president name of USA. And okay, I would like to know the head. Okay, so I just want to get the head from this data, because I guess if I want to know only the head, so I can just do the data and the array, okay, and the concept of the dictionary. So we can just call the column name, or you just call the key. Okay, so when you run this one, then you will get all the data from the column head. Okay, so this is the column name. Okay, after you have this one, okay, let me just delete this one. So I would like to use NP array. So I want to convert the data in the head, in the column head, into array format from the Numpy. Okay, so we have the value in the array format. So it is in the list format, and all the data are now in the NP or in the Numpy library. If you know from the first, from the explanation before about the statistics, So we can get the mean, standard deviation, the minimum, and the maximum. So those functions are from the library. This one, we can get the minimum, standard deviation. We can find the minimum and the maximum. And if you check on this data set, it seems all data are set, no missing values. So you can just go with the basic statistics without any AN. So you can see the mean. Okay, the mean height is 179 and the standard deviation is 6.9. The minimum is 163 and then the maximum is 193. Okay, and if you want to see the other statistical descriptive, and you can see the percentile. Let's say I want to know the percentile of heights and I want to know the 25% percentile. So this is the result. And I want to know the median. So the median means the percentile 50, or you can just use the median. And the 75 percentile means this is the from the data heights, and we want to put the 75 percentile. Then you can get the information. The 25 percentile is 174, 182, and 183. So the median of the US president is 182 cm, a centimeter. Yeah. And because it is only the basic explanation about this data analysis, I just want to shortly give you the introduction about the data visualization. In the next chapter, I guess, in the next chapter, I think I will discuss about the visualization. I said this one is the chapter 4. Actually, I took, if you want to refer to one of the files, I have that one. But yeah, now let's just focus on this file. So this is a file to include another library, which is matplotlib. Yeah. So we also will learn about this matplotlib later. This matplotlib is one of the library for the visualization. We call this matplotlib inline in order to show the visualization in Jupyter Notebook. And we want to import the matplotlib.pyplot. And we can just put the PLT. PLT is the shorten of those library. And if you want to make it a good styling for the visualization, we can use the Seaborn. So the Seaborn is just to make a good visual from the graphic. And once you import this one, let's just set. Yeah, so this is to set the plot style. And run this code, run the cells. Okay. And after you run the cells, I want to know the histogram. So the histogram means I want to see the distribution. Yeah. So in the next section, I will explain about this one. So here I would like to put the heights, the variable heights we already have before heights, into the histogram by the matplotlib. And the title of the graph will be height distribution of US president. So you can see this one, height distribution of US presidents. And the X label will be the height, okay? And the Y label will be the number. So from this graph, we can see the number of presidents who have height like in the range of 165, they are 1. And the number of presidents who have the weight in between, I guess this one from 160 until 165, 165 to 170, okay, there are 2. And then from this one is now, this is 170 until 175. So I think they divide the range like 170 until 172.5. So there are 3. So now they're 172.5 until 175. There are 5, okay, and so on. So many of them are in the range of 180 until 182.5. Okay. Yeah, with this visualization, it will help you to analyze the data more later. Now, I would like to reshape. You still don't know what is a reshape? Okay. So in the reshape, let's say I want to distinguish to 6 and 7. So 6 means the 6 rows and 7 means the 7 columns. Okay. Now you can see, yeah, the details now will be separated into 6 rows and 7 columns. Now, whenever you have an array, you can just make a reshape, and then you can reshape based on the numbers. Because we have 42 rows, then you can easily make it as the 6,7. So later you will also see some of the problems that might be reshaped. Yeah. So I will give you some assignment also about this one, how if I have this kind of data, and if you want to reshape it into the matrix format or 2-dimensional, then after you reshape, you need to do something with the analysis. Let's say I want to do the summation. Okay? So you can see that, okay, the summation of this to column is 1073. So you can, if you still remember, if we want to do the summation according to axis 0, so we want to sum based on the column. So this is the column 1, column 2, column 3, column 4, and so on. So we will get the result of this one. 1073 is the result of the first column. And if I want to know the mean, okay, yeah, you can also use the other kind of statistical measures. Now I want to know the mean, and then the axis equals to 1. So the axis equal to 1 means the row. Okay. So the row here, I want to get the average. So this is the average of the row 1. This is the average of the row number 2. This is the average of row number 3, and so on. Okay. Then, yeah, I think that's all. So this is the end of the chapter of the Numpy. And yeah, I hope that you can learn something. And in next video, we will learn how to deal with more data. And of course, this is the basic. And after this video, I will give you also some assignment. And again, the course-based quiz will be available for you to review what you already get on this video. Okay, that's all for today. Thank you very much for listening, and see you in the next video.